basicsxx. Solve 3x squared minus 60 equals 0. Please simplify your radical. So, if I was doing this one, but what do I know, right? First thing I would do is I'd move that 60 over and that change its sign to positive. That was, add 60 to both sides. If you need a rule, what happened? The next thing I would do is I'd divide out that 3. Divide both sides by 3. And the next thing I'd do is I'd take the square root. And I'll switch over to the pen here. So x is going to be plus or minus a root of 20. And I square rooted both sides. That's what I did with that. Anyways, root 20 is not a hard thing to simplify. Root 20 is going to be 4 times 5, which is root of 4 is 2 root 5. This one's not imaginary. All right, it's a real world number. And the truth is, imaginary numbers aren't on your EOC, so I'm going to slow them down for a while. Anyways, that's number 1. Should be an easy problem. Should be something 99% of my student body gets right. We'll see. We will see. All right, number 2 says solve log base 3 of x minus 1 equal to 3. And I'm going to write in the understood base here, which is a 10. And then I'm going to use log as base. This is my base is 10. My argument is 3x minus 1, which means my exponent has to be a 3. So 10 cubed, because the base is 10, the exponent's 3, has to be equal to 3x minus 1. 10 cubed is 1,000. We're going to do 2 steps. We're going to add 1. 1,001 equals 3x. We're going to divide by 3. So x is simply 1,001 over 3. And please, no decimals. Please, no decimals. Just leave it. Number 3, solve the factored polynomial. So this will be multiple select. Show the initial setup. You're just going to use the zero product property. And I'll take this out. That's what this is. It's the zero product property. We should be able to get this by the zero product property. X plus 4 equals 0. We do a simple shift right. X is negative 4. Notice how the signs changed. Was positive becomes negative. 3x minus 5 has to equal 0. So that's a 2-stepper. We're going to add 5 to both sides. 3x is equal to 5. Then we're going to divide by 3. X is 5/3. Every single junior I have should be able to do that problem. I've got one more to go. It's the last one. But I have negative 4. I have 5/3. And I got one more. 2x minus 1/9 is 0. 2x is 1/9. X is 1 divided by 9 times 2 because we're dividing by 2. The division step happened there. And that gives me 1/18. 3 answers, and they weren't hard to get. This should be a question for everybody. Everybody should get that right. All right, moving on to 4. 4 is using what's called the remainder theorem. This is remainder theorem. Remainder theorem says if f of c equals 0, then we know a lot of stuff. X equals c is a 0 of the polynomial. All right. Change the sign. X minus c is a factor, which also might mean divides evenly. That's what that means. That's where that comes from. And the remainder, when dividing f by either x minus c, or if you're using synthetic division, x equals c, I should just say, let's just do it this way, is 0. And there's one more thing it can actually say. Well, actually, it's right here. F of c is 0. And by the way, 0 is another word for root. So don't be surprised if that shows up sooner or later, but 0 is another word for root. But there's a couple answers here. X minus c is a factor is one of them. C enters F evenly. X equals c is a 0 is one of them. This is not, because the signs have to change. The c was positive. Be careful about that. And the remainder when dividing f by x minus c is 0. There's your 4 choices. Memorize them. Plain and simple. Solve 2 natural logs of 4x minus 3 equals 7. By hand answers it in terms of E get full credit. Y1, Y2 answers expressed as decimals get half. You should, and by the way, you should check and calculate. But anyways, I'm gonna put this little E here. But the first thing I have to do is I'm gonna divide everything by 2 because I want that 2 gone. So log base E of 4x minus 3 equals 7 halves. Now I'm going to find my base. My base is E. Oops. My base is that E. Looks like that, lowercase e. Its argument is 4x minus 7, 3. And the exponent has to be 7 halves. Do remember this. Remember b to the e equals a. So I identified all these pieces. So the base is lowercase e. She is raised to the 7 halves. She has to equal 4x minus 3. That's what she has to equal. This thing has 2 steps. We add 3 to both sides. And then we divide by 4. And there's my answer. Now, I'm going to go push some buttons so that I can check myself against y1, y2. But I came up with E. I forgot my plus 3, didn't I? I need to wake up, don't I? Go back a couple of steps here. I had to add 3 to both sides. There we go. There's my answer. Let's see what that looks like. So math, sorry, I'm there it is. Math, num, n over d. E, which is raised to the 7 halves, which would mean to take the square root and then raise it to the 7th. Is about 9.03. Let's go to the calculator. In case I'm that kid who just cannot do logarithms, so you get a little bit of credit, which is something. The name of the class is growth, kids, so be figuring out something. When the year's over, I've got to find a way to grade you appropriately as to what you knew coming in. Anyways, there's y1, there's y2. Zoom 6. And then second, trace 5. Enter, enter, enter. Oh, I gotta get cursor to show up first. Let me see the cursor and then enter, enter, enter. Just like it said earlier, 9.028863, 9.028886, and see, this is a little more accurate. All right, number 6, determine the average rate of change for g of x is 2e to the x minus 1 plus 2 over this interval. And there's a small bonus for doing it in perfect form. So your formula says the average rate of change is f of b minus f of a over b minus a. So I'm going to plug this stuff in. This is A, this is B. F of B is legit 2e, 3 minus 1 is 2, plus 2. F of A is 2e, negative 1 minus 1 to the negative second, plus 2. Now, again, I'm doing the perfect form right now. The perfect form would be 2e squared plus 2 minus 2e to the negative second plus 2, sitting pretty over 3 minus a negative 1. So the bottom's going to be 4. And these guys are not alike, but here we have 2 minus 2, which is nothing. So we have 2e squared minus 2e to the negative second, and everything up here is divisible by 2. E squared minus e to the negative second over 2 is the perfect form. Perfect form. And I said I'd give a small bonus for that. Now, if that bothered you, that's okay. You still get full credit if you can be a button pusher. Again, same formula. F of B minus F of A. Sitting pretty over B minus A. I'm amazed at how many juniors can't do arbitrary change yet. I really am. Anyways, to find F of B here, I'm just going to use a storage feature on the calculator. I'm going to take a 3, store it to x. So 2 second e to the x minus a 1 plus a 2 is about 16.7781. F of A, again using the storage feature. This time I'm going to take a negative 1, store to x. Up, 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 enter, enter. Is about 2.2707. And I'm just going to throw crap at this formula. 16.7811 minus 2.2707, sitting pretty over 3 minus a negative 1. I'm going to do this in multiple parts. See, I have this minus that, enter, and divided by 3 minus negative 1, 4. And just be pushing buttons, make sure you can get it. 3.6269. That's the average rate of change over that interval. If f of 3 is 2, what do we know? Multiple select. Now, this is also remainder theorem. This is not a 0. This is saying that when x equals 3, the remainder is 2. That means we're at several things, because the remainder is not 0. I know that x minus 3 is not a factor. If it was a factor, it would have a remainder of 0. It doesn't enter evenly. It is not a 0. This is just completely screwed up because the signs didn't even change. X equals 3 is not a 0. I need to have, well, I don't know what I have to do. And the remainder when dividing f by x minus 3 is 2. There she is. That's what I was looking for. And that's it. Not a factor, not a 0. Remainder's 2. I don't see anything else is missing. All right, solve using the quadratic formula. Feel free to start singing this to yourself. Does x equals negative b plus or minus square root b squared minus 4ac all over 2a. Now, a couple of y'all can't do this, but a is 3, b is negative 6, c is 4, baby steps, plug it in. Opposite of a -6 is a +6. Plus or minus. If you're going to square a negative, either drop the symbol or just wrap it in parentheses. A is 3, C is 4. All over twice A, twice a 3. So you have 6 over 6 there, plus or minus. And that 6 isn't going anywhere. It's under both pieces of the numerator. Inside the radical is 36 minus 48. -12. Now don't do something simple here, silly here, like divide -12 by 6. It is imaginary. The root of -12 is the imaginary root of 12, and 12 is 4 times 3. And the root of 4 is 2, so 2i root 3. 6 over 6 is 1. We have 2i root 3 over 6. And 2 over 6 is a third. And there's the QF. Ta-da! 9 is a synthetic division problem. Use synthetic division to determine the quotient and remainder of this dude. And this has to be talked about repetitively. If x minus 2 is a 0, then x minus 2 equals 0. X equals 2. It's a positive 2. You always change this sign as you go up front. Now I need coefficients. I need a placeholder here. There's no x cubed. 2, 0, -3, 4, -4. We drop, we multiply, and we add. 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 That should be 28. I was thinking about the final answer. I'm just checking to make sure I didn't make any mistakes. And it doesn't look like I did. This is my remainder. Notice it's not 0. X minus 2 is not a factor. It's the remainder theorem. Constant x squared, x cubed. So if I write out the full quotient, I have 2x cubed plus 4x squared plus 5x plus 14 plus 24 pieces of the divisor, x minus 2. Move forward, 10. Given 3 terms of a sequence, -7, -1, 5, write a rule. Now I noticed that this one has a difference of 6. I'm just going to go over here and look at this thing. The nth term is the first term, -7, plus parentheses n minus 1 times the difference of 6. And then I kick in the distributive property. So -7 plus 6n minus 6, and I combine like terms, 6n minus 13. Because -6 and -7 makes -13. Find the sum of the 10th through the 23rd terms of this sequence. And the hint here is the first is the 10th term, the last is the 23rd. And I also need to know n. N is going to be 23 minus 10, add 1 back, which should be 14. So I'm going to find the sum of 14 things. Everywhere I see an n, I have 14. To find the first term, I plug a 10 in. And that's going to yield -53. To find the last thing, I plug a 23 in. That should be -118. Feel free to push buttons there. Feel free to check me. -53 plus a -118. That's -171. I'm going to check myself. It is early in the morning. If I was going to make a mistake, it would be something silly like subtraction. Yeah, I'm good with that. Anyways, I reduce 14 over 2 because I can. Negative 1197. All right, moving forward in my life. 12, the geometric sequence is given as 3 9/2, 27 fourths. They both have recursive and explicit rule for the sequence. Now, if you don't know R is going to be the second term over the first term. Because a lot of you would struggle with that. But I would take my 9/2 and I would divide it by 3. And there she is as a fraction, 3/2. Okay? So I'm looking at this thing in 3/2, and I've got the rules for you. If I'm doing this explicitly, I am the first term times the ratio of 3/2 raised to the n minus 1. And that's explicit. Recursively, I would be a sub n equals my ratio of 3/2. Notice I've got the formula right here. Times a sub n minus 1, but I have to define the first term. The first term is a 3. That's pretty much all there is. 13, find the sum of the 5th through 12th terms of this sequence, and I've given you a formula over there. I didn't do the infinite sequence on here. That says first term, it's actually this guy. That should be a sub 5 to use this thing, because the first term I care about is the 5th term. So I'm going to find the 5th term. She's 2 times a negative 3 to the 5 minus 1. So 2 times, should be negative 162. I'm sorry, positive 162. I don't know what 5 minus 1 is. Watch this. 5 minus 1. 162. All right, how many things are there? And again, as always, the high minus the low, add 1 back, which is going to be 8. Seems legit. And now I'm going to find the sum of 8 things. It is the first term that I cared about, 162. Comes 1 minus. Be careful about your R here. Wrap it, just for good measure, to the 8th, because n was 8. I've really seen n have an 8. Over 1 minus a negative 3. So we got 162, set of parentheses, math, num, n over d, 1 minus, didn't stick, 1 minus parentheses, negative 3, rooftopped to the 8th power, and I'm just going to type a 4 in the bottom, but if you don't know what 1 minus negative 3 is, so be it. Negative 265,680. And there you go. Not too hard. 14, completely simplify the expression such that all exponents are positive. It is a complete simplification. 26 over 96, sorry, 24 over 96 is going to be a quarter. Math, enter, enter. So I'm looking at 1 over 4. No one's probably understood. Now look at each of these things. E to the negative second over e to the negative 5th. That would be thought of as maybe e to the 5th, e to the negative second, which is e cubed. That's one way of doing it. You can move things around. All right, then we have x to the 10th over x to the 14th, and our rule says we can subtract exponents. So an x to the 4th in the denominator. 2 more to go. And I'm done with this thing for today. Completely simplify the cubic root of 81 x to the 7th y to the 6th. So I know that 81 is 3 to the 4th. So this is the cubic root of 3 to the 4th, x to the 7th, y to the 6th. Now the deal is, I wonder, let's just do it like this. Let's use P over R. It's one way of doing it. So I have 3 to the 4th over 3, x to the 7th over 3, y to the 6th over 3. And I'll go back and do this a different way too for you. But anyways, 4 enters 3 one time. There'd be one piece of 3 left. 3 enters 7 twice. There'd be one piece of 3 left. 3 enters 6 twice. So I get all these nice things done, and then I still got this. This is just one way of explaining it. Third root is the cubic root, 3x. That's one way of doing it. Now, the other way of doing this is pretty simple too. None of them are hard. But we divide power by the root. And the remainder stays inside. Anyways, 3 enters 4 one time, but there's a remainder of 1, so 3 stays inside. 3 enters 7 twice, remainder of 1, x stays inside. 3 enters 6 twice, remainder of 0. They're both the same thing. And the last one, solve using the graphing ability of your TI-84. You must write y1, y2 as though you're using change of base. And I left change of base on there because half of y'all hadn't figured it out yet. I'm going to use the LNs. This is going to become the ln of 6x minus 6 over the ln of 2. And then take away a 3. This is going to become the ln of 4x minus 8, sitting over the ln of 4. And then plus a 1. And I'm going to go to y1, y2. So what have I got here? I got the ln of 6x minus 6. Sitting pretty over the natural log of 2. And then minus 3. And in y2, I have the ln of 4x minus 8. Sitting pretty over the ln of 4. And then plus a 1. And I do a zoom 6. And this one does have 2 answers. No one on your test will have 2 answers too. You're going to have to learn how to play with your windows sooner or later. All right. First answer, second trace, 5. Where's my cursor? Notice I'm pressing that button for a while. Enter. I had to press the cursor there a little bit too. Enter, enter. There she is. And you might have to push buttons on these for a while. But I got 2.0379. 2.0379. 2.0379. All right. Now the other answer is probably over here to the right. You can see that blue curve's catching up with that red curve. So I'm going to adjust my X max out to around 40. For no good reason, just picking 40. There's the other answer. Second trace, 5. I get my cursor close. Enter, enter, enter. There's the other answer. About 28.4066. 28.4066. And there is basics 20, and it is a basics. It is basics 20. And that's all I got for you for right now. Hope you enjoyed.